Okay, so we are in chapter 13, as it says right here, ANOVA, which ANOVA, this is our last topic. This is the end of the course. What is ANOVA? This stands for, it's an abbreviation, an acronym for analysis of variance. Analysis of variance is what that stands for, ANOVA. Analysis of variance, and it's a statistical study to look at three groups. So notice here, this is specifically, it's when we have three or more groups. Or let me say it this way: when two or no, not two or more. Sorry. When we have, I'm sorry, I should have said this better. When we have more than two groups. That's the key. Let me put a box around this part right here. More than two groups. Let me highlight it. Doing all I can to emphasize these words. More than two groups. So when we have more than two groups, notice how we have down here, group number one, number two, and number three, right? In this example here, let me just do it this way. The groups are number 1, 2, and 3. We're talking about some kind of, this question says, is a statistics class delivery type a factor in how well students do on the final exam? The table below shows the average percent on the final exams from several randomly selected classes that use different delivery types. In other words, does it make a difference if you take a statistics class face-to-face or hybrid or online? It's a funny time for this question, huh? We're in the COVID days right now. And so we can't do face-to-face. I've taught statistics face-to-face many times. And of course, I do prefer that. I can directly interact with y'all a little bit better and I think be a little more helpful. Hybrid, that's a mix. Hybrid is like half online, half face-to-face. So you meet, a few times, you meet on campus, maybe only once a week or something, and then half of the class is online. It's a mix of that. And then online is like what we're doing, purely online. So does it make a difference? That's the question. Is the delivery type, is it a factor? Does it make a difference? Let me put it in more simple language. Does the method affect the grades? Does the method affect the grades? Do we get different averages, means, for the three groups? Right? That's what we're testing. Does that question make sense? That's what we're testing. We're testing and we're saying, hey, for these three different groups, does it make a difference? Right? Do people do better in face-to-face? Or do they do better in the hybrid, the mix, that's half online, half face-to-face? Or do they do better online? How could we, so that's what we're trying to answer. So again, statistics is trying to answer real life questions. This is something that education people like myself would care about. I want to know, does it make it harder for students to take this class online than face-to-face? How's all that work? So what could we do? What could we do to answer that question? Oh, first off, let me mention, do you see how this is different? Let me give a comparison, because the trick is going to be to recognize all of this stuff on the final exam. By the way, this chapter 13, is not on exam 4, but it's on the final. So this is not on exam 4. It's on the final though. So this concept will be on the final exam, along with everything else we've done, most everything in the course. But it's not on exam 4. It's on the final. So anyway, on the final, when you have most all of the course there at once, how are you going to recognize this is an ANOVA question? I'm not going to say the word ANOVA. Just like these words, don't say the word ANOVA. These are the kind of words you'll get on the actual exam. How will you recognize that you need to do this new thing, which we're about to do, called ANOVA?
It'll have more than 2 groups.
Yeah, exactly. We have more than 2 groups. Let me give you a comparison. Yeah, you've got it. Right here. Here's a question from earlier in the course. This is a question that we did previously. This will be on the final exam. I don't know if you remember this one about the bracelet and whatever, blah, blah, blah. How would you, as you recognize, now that looks a lot like the one we're about to do, but what's different? How would you look at this and know that it's not ANOVA?
It's only comparing two things with a bracelet and without.
Beautiful. Are we all getting that? I really want that to be. So that's the key identifier. If it's only got 2 groups, then you do the stuff we learned before, which, we learned about comparing 2 groups, and I won't review all that right now, but we have done that, right? How to compare 2 groups, the difference of means and all that kind of stuff. That was for 2 groups. All of that was for 2 groups. Now, what's new today, what we're learning new today is, well, how about if you have more than 2 groups? How do you compare more than 2 groups? Remember all those things on your calculator? Let me go back here one more time to this. Remember all those things on your calculator? They're all like, in fact, here, maybe, let me copy this so I can write on it. Let me bring it back here. Remember those things on your calculator? Let me put it right down here at the bottom. Are all 2 prop. Here it is. Yeah. So for this right here, what you would do is you would do some kind of 2 prop Z test. Or actually, this one is a matched pairs. So anyway, but I don't care about the details. Remember all those 2 prop things, right? We had 2 prop Z test, 2 prop Z interval, 2 sample this, 2 sample that. Remember all those on your calculator? Well, obviously, those are for 2, right? 2 groups, bracelet, no bracelet. So we learned how to do all those tests for 2 groups. Well, now what we want to say is, well, what if we have more than 2 groups? Real life, you don't always just have 2 groups. Sometimes you do, but sometimes you have 3. Like right here, we have face-to-face classes, purely online classes, and then the mix. Hybrid is half online, half face-to-face. Maybe that's the best option. So we want to actually compare 3 groups. So that's how you're going to recognize this on the final exam. And as soon as you see 3 groups, you go, oh, I got to do ANOVA. I got to do that ANOVA thing because I've got more than 2 groups. I can't use all those 2 sample, 2 prop Z things on my calculator. I've got to do ANOVA. All right. Good. So that's the first thing. That's what's a challenge. In a math and science class, you always want to practice recognition, especially on a final. So as you go over the practice final, which we're going to start today, you want to just go over and over and over, practicing, making sure you can recognize different problem types because they're all mixed up. And it's been, 4 months, almost 3.5 months of learning different statistical techniques. Okay. Anyway, let's get down to it. Now, let's be real for just a second. I really, really, really think that's going to be the most helpful thing to you. What is the purpose of it? Why have we tortured you with all this statistic stuff for 3.5 months here? It's because we want you to be comfortable as a consumer of information in the 21st century, the information age. Tons of information is always going to be pouring out, is currently pouring into your life through the internet and other sources. So how can you be a wise consumer? Well, let's be real. Try to be as real as you can with me. If I asked you this question, suppose it was your job, your boss gives you this question and says, hey, I want you to decide, suppose you start working for some school and they tell you, okay, we'd like you to figure out if the students are doing better in the face-to-face classes, the hybrid classes, or the online classes, please. here's some data we have for how they did on the final exam in the face-to-face class, the hybrid class, and the online class. Can you please figure out for us, give us a report and do some statistical analysis, give us a report and tell us which, if it makes a difference. Does the face-to-face online hybrid, does it make a difference, or are they all the same, or do students do the same in all three classes, or does it make a difference? So what would you do? Let's just forget about all the fancy stat stuff for a minute. Real life, what would you do? How could you figure out if they're all the same or there's a difference? This question making sense? I really want you to think about it. I think you get a lot more out of this if you think about this question with me. How can we decide, how do we decide if all three are the same results or different? How do we decide that? So I don't mean a fancy ANOVA. I don't expect that you know all this ANOVA stuff. I don't want you to do anything fancy. Just pretend you're a man or woman on the street who's never taken stats. What could you do?
You could take the average of all of them and then compare the averages.
Beautiful, Natalia. Beautiful. That's exactly what I'm looking for, right? That makes sense, doesn't it? Couldn't we just find the average for the three averages? In fact, I'm going to do that real quick. I'll do that. I'm going to add all the, remember how to do an average? Just add these up, right? And divide by, how many are there? 1, 2, 3. There's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of them. I'm going to add those up and divide by 8, right? You guys know how to do an average. So I'm going to do that real quick. I should have done that beforehand. Had that ready to go. I'm kind of doing this on the fly. I didn't plan on doing all this touchy-feely stuff, but I really think it's important. So 80.75. So the first group, the average came out 80. I just added up those numbers and divided by 8, you know, how to do an average. And I'm going to do that. Now I'm going to do the next group. Add those up, divide by 8. Real quick here, maybe real quick, maybe not. I got 72.6, I'll just say 6, goodness, 625. And then the third group, same thing, gonna add them up and divide by 8, because there's, so basically notice we're taking 8 students from each group, aren't we? So 8 students, I suppose, randomly chosen from each class. 1, 2, 3, 4, 5, 6, 7, 8, 8, and I'm getting the 72.5. Okay. So what do you think, guys? I just did the 3 averages, guys and gals out there. I think mostly gals. I should say gals. What do you think? Mostly gals and a few guys. What do you think about teaching these 3 different ways: face-to-face, hybrid, and online? Are they all really the same results, or are they different?
Face-to-face is different than the other 2.
Yeah. Doesn't it seem like face-to-face came out with in fact, it's different better, huh? I think that's kind of how real life is. I think face-to-face is better, and the average comes out a little higher. The other 2 are about the same, and the average is a little bit lower. So wouldn't you say, from this simple calculation of finding the average, you know, these are eight students in the face-to-face class, randomly, I assume randomly selected, and these are 8 students from the hybrid class, randomly selected, and these are 8 students from the online class, randomly selected, and the averages, we just figured out the average, and the average for the face-to-face class was higher. So are all 3 the same, or are they different? We would say different, right? Different. Specifically, the face-to-face is different. The average is higher. It's better. We're done. Game over. Problem done, right? Man on the street who's never taken statistics, who just knows how to figure out an average, man or woman on the street, can just add them up and divide by 8. Why are we going to do some fancy ANOVA test? Isn't that good enough right there? Just there's the average. Are they the same? No, they're different. Face-to-face class did better. They're different. Game over. Problem over. I don't need some fancy. Why are we taking this class? Why have we spent 3.5 months of your life, some of the best years of your life, taken to do all this statistics, all these fancy calculations? And why do people in the real world run all these fancy statistical calculation things when all you got to do is do an average? You probably knew that before you came into this class. You can average a group of numbers, add them up and divide by 8. There's a problem. That's not the final. It's not that simple. There is a reason we spent 3.5 months, and people in the real world don't just do this. They do this to begin with, but this isn't all they do. Why not? What's wrong with this? Why doesn't this answer the question? What's the problem? Have I not said it enough by now? Let me say it again. I'm hoping it's becoming more and more clear in your minds. This is my last lecture on the new material anyway, so I really hope it's becoming clear. Here, I'll write it as clearly as I can. What about, what am I going to say? Anybody know? I've tried to say it as many times as I can. What about luck? What, you understand what I mean? Maybe this was lucky. Maybe it was a lucky 8 students, and all 3 groups are really the same, or all 3 methods, I should say, right? All 3 methods are really the same. Are you tracking with me? Maybe it was just a lucky group. You just, because we randomly grabbed 8 face-to-face students, 8 hybrid, 8 online, figured out their averages. Yeah, this group came out higher. I agree, 80 is higher than 72, but maybe that was just a lucky 8 students, and all 3 methods are really the same. If you kept testing more and more and grabbed another, you grabbed a bigger group, maybe grabbed 50 students for each of the groups, you would find out that their averages are really all the same. Really, the methods don't matter. Really, they're all the same. Maybe this was just lucky. We just got a lucky group of 8. That can happen, right? You can randomly happen to select a lucky group of, you just happen to get the better students by random luck. So yeah, their average was higher, but that's not really true of face-to-face classes in general. They're not higher average. That was just lucky. What about luck? That has been the problem all throughout our course. Did you catch that? Does that make sense? What about luck? So now you might think, well, yeah, who cares? It probably wasn't luck, but it's easy to say in something like this where the stakes seem kind of low, whether face-to-face, hybrid, or online is better. It's maybe not the biggest deal in the world. But how about if they were testing COVID, which is a big deal to us all right now, the vaccines, the new vaccines they're coming out with for COVID. And what if they have vaccine type 1, vaccine type 2, vaccine type 3, which they do right now, have different types of vaccines. And they test it on various patients, which they are right now. And the results come out a little bit different. And this vaccine seems to do better. The question of what about luck is huge to us all, to the whole world. isn't it? We want to know, is this vaccine really better? Or did we just happen to get a lucky 8 people that we tested it on? We need to know. Because if this vaccine is really better, we want to give it to the entire world. But if they're all the same, then it doesn't matter. And these companies want in on the action, I'm sure. And also it'd probably allow for wider distribution. So more people could get the vaccine quicker if we can let all 3 be distributed. So we need to know. So there's questions like this in business, government, obviously medicine, that are very, very, very important to our lives. This is why statistics matters and why people care. Because, and this is why you cannot simply just do an average. That's not enough. That's a good first step, but that does not really settle the whole issue. Why not? Because what about luck? Do you understand that? Is that making sense? What about luck? Could have been this is just a lucky group, or maybe it wasn't a lucky group. How do we figure that out? What calculation do we have? It's our number one calculation. It decides every hypothesis test conclusion. What calculation tells us the chance of luck? Oh, please make my day today. Make me happy and tell me you know the answer.
The p-value.
Thank you. Exactly. P-value, right? In every hypothesis test, we figure out the p-value because the p-value, what is the p-value? The probability of luck. Is that making sense? That's going to be on the final exam as a straight ahead question. So it's so important to everything we've done. I hope you understand. That's exactly what p-value is. It's the chance of luck. It's the chance that you just happen to get a lucky 8 people. You see, there always is a chance that maybe randomly you got a lucky 8 people. And so if that chance is really, really low, we're going to say, no, we didn't get there's no way we got a lucky 8 people. This is really the truth. This vaccine's really better, or this way of teaching face-to-face is really better. Right? This is exactly what they do in a court of law. My daughter went away for her first jury duty this morning. She's downtown at the courthouse, appearing for her jury duty. She's kind of excited. She wants to be on a jury. Anyway, what if she gets on a criminal case? The judge will read to her the law at the beginning, and it will say, you must decide this case if the evidence is what? Beyond a reasonable doubt. You see, because just like in criminal cases and in statistics, that's really a statistics concept. There's always the chance it's luck, right? If somebody says, well, I saw the person in the vicinity when the crime was done, they had a motive. Yeah, but maybe that's just luck. Maybe they were just luckily happened to be in that area on that day, and maybe they're connected with the person with the crime, but maybe that's just coincidental luck. Or if there's enough evidence, like several eyewitnesses and all that kind of stuff, DNA, blood samples, at some point we say, all right, this can't be luck anymore. No way. This is evidence beyond a reasonable doubt. Same exact thing. Does that make sense? I hope the big idea of statistics is making sense for you. That's why we spent 3.5 months learning all these fancy tests, because basically we have to rule out luck. It's kind of funny, isn't it? You could subtitle statistics, or what about luck? Really, that's it. We are just having to rule out luck time after time. We have to know, could this have just been a lucky group of 8? Or is the chance of luck so low, is the p-value, the probability of luck, so low that it's beyond a reasonable doubt? And we think, no, they're really different. All right, enough with the introduction. I hope that makes sense. That's what it's all about. That's how the real world works and why people care. Whoops, I went a little too far on that. There we go. Let me erase again, but not erase the average. I like having those averages there. That's why people care about statistics and why we have spent 3.5 months. And that's what p-value is all about. P-value is a probability but the results are just luck. All right. So because of all that, we have to do something more fancy than just figuring out the averages. That's a good first step. It's not required. Now, nobody's going to ask you to do that. It was fun. I enjoyed it. I hope you enjoyed it, but it's not required. Let me write that. Not required. I just did it for fun. It's not required to do this problem. You do not have to do the averages. Not required. All you've got to do is the ANOVA test, the analysis of variance. So basically what we're going to do is we're going to compare this group. The ANOVA test is going to compare these three groups and find out if their averages, their means, are all three the same or different. Of course, we've already done them and we know one of them is different than the other two. But the question is, maybe that was by luck. And so the ANOVA test is going to tell us the chance that it was by luck, what we call the p-value, right? Probability of luck. And if that's really low, we'll think, well, no, it couldn't have been luck. And then we'll believe they're different. That's basically the gist of what the ANOVA test is going to do. All right, let's do it. So how do we actually do it? Back to your notes. Right. Oh, that's not it anymore. I went somewhere else. Let me grab it. So exam, there it is, exam 4 notes. All right, so exam 4 notes. I'm looking at exam 4. There it is, number 9. The ANOVA test. That's right, I put it over here too. Yeah, so right down here. I should have just gone right there. There it is. So the ANOVA test. How do you do it? So the HO is it's nice. It's always the same thing, and that is that 3 or more populations have the same. So HO is that they're same, and H1 is that at least one of them is different. It's that simple. HO, they're all the same, 3 or more populations. All 3 groups are the same mean, same average, and H1 is one of them is different. And then you put L1 down, put list 1 down L1, list 2 down L2, list 3 down L3, etc. This is pretty easy, really pretty easy. So let's do it. So these 8 students,
Quick
I'm going to
question.
come up here. And, oh yeah, see the HO is already filled in for you. That says mu1 equals mu2 equals mu3. That's mean, right? That's average or mean. That stands for mean. Mean 1 equals mean 2 equals mean 3. So now we're going to go to our calculator. So go to your calculator and let's put the stuff in L1, L2, and L3. So I'm going to show that real
Mr.
quickly
Herring,
for you.
Mr.
Let's
Herring,
go to the calculator. Where's my calculator? There it is. All right, got it. All right, so I'm going to push stat. I'm already on edit. That's perfect. Hit enter. And there's L1, L2, L3. They're already clear. If they're not clear, go ahead and clear them out for yourself. So 92 and then down and 97 and down and just keep on going. Put your data down there. I think you get the idea. I think it's going to be better, more helpful for me just to write it out for you. So let me do that. I'm going to go back to the iPad and just write out what you're seeing here. All right. Here we go. So let me do that. So I'm going to put this is L1. This is L2 and this is L3. L1, L2, L3. And kind of running out of room here. I'm going to have to erase this over here. So step 1, put the data down L1, L2, L3. Step 2, so what's next? So here's the steps. So put L1, L2, L3, go stat, test, ANOVA. So now we're going to go step 2 here. Hit the stat button. Go over to test. go down to ANOVA. And real quick, I got to put my numbers in. I have not done that. Get some numbers for you. So I'm going to put my numbers in. So type your numbers down, L1, L2, L3.
Mr. Heron, I have a question.
Yeah.
Because on mine, like the hybrid section has more responses than the other two. Does that matter?
Good question. It does not matter. Yeah, it's totally fine. Mine just coincidentally happen to all have the same, but they don't have to. They can have a different number. Great question, Natalia. Yeah, it's okay if some lists are different, longer and shorter than others. Yeah, totally good. Just go ahead and type them down, L1, L2, L3. Calculator can handle it just fine. Great question. And so then ANOVA is way down at the bottom for me. For me, it's H. I think it probably is for you as well. Go all the way down to ANOVA and hit enter. And when you do,
Mr.
you'll
Herring,
get the words ANOVA will appear on your main screen with a parenthesis. And so what you type in then is L1, comma L2, comma L3. If you had 4 lists, you would do a 4th one and then close the parentheses and hit enter. Now you may or may not know how to get L1, L2, L3 to appear on your screen. So let me tell you how to do that. So you get those to appear. Let me get this out of the way. You get those to appear by hitting 2nd and 1. And for this one, 2nd and 2. And for this one, same thing, 2nd and 3. Got to hit the 2nd button. So hit 2nd 1, comma. Don't forget the commas. Those commas are important. You got to have commas. Notice how I have these commas between them. You got to have those commas between them. The comma is right above the 7 on your calculator. And then just hit enter. When you're done with that, just hit enter and it'll give you the results. And you know what we care about specifically is we care about the p-value, but they do ask us for a couple other things. They ask us for what's called the test statistic. I'll come on down and show you about that. The test statistic is F. It's right here. So I'm on this slide right now. Oh, for this study, we should use, what should we use? Does it have, I don't even remember what the options are. Does it have ANOVA as one of the options? But,
yes, it does.
oh, okay. So yeah, then just go with that then.
And Mr. Heron, I know that there was somebody trying to get your attention. I think they had a question.
Oh yeah, question, go ahead.
yeah, so I see how yours says face-to-face, hybrid, and then online. Does it matter what order, like, because mine is different. Mine says hybrid, online, and then face-to-face.
Oh yeah, good question. Doesn't matter. Just go ahead and put the first column down L1 and the second down L2 and the third down L3. Yeah, good question.
Okay.
Doesn't matter what order they're in. It'll work. Good. And then for the F value, I'm getting, see, they want 3 places. I'm getting 1.028. And we don't really care about that. We don't do anything with that. And then the p-value, that's what we really care about. My p-value is coming out to be 0.3749. 4 places. 3749 is what mine came out to be. And that's the big deal for us, right? Because what is that? What is p-value? Probability of luck, right? P-value, whoops. P-value is always the probably p-value. And every time we do a hypothesis test, it's the probability that the results, whatever results we're getting, are just from luck. The probability the results are luck. So this is a 37% chance. That's a pretty big chance of luck. In other words, you could have got this 80 being higher by luck. What's the chance that would happen? 37% chance. It's not real likely, but it's not super unlikely either, is it? And how tight of a test did they want? Right over here, here's our alpha. I don't know if you, significance level is right there, alpha 0.1. So the question is our p-value, let me come over here, p-value 0.3749. How does it compare to our alpha level? That's always the deal, right? 0.1, that's like 0.10, isn't it? Mine is anyway. So what do you think? Is the p-value higher? Yeah, for sure. The p-value is higher, isn't it? In other words, we have a chance of luck that's too big. That you could have got that higher face-to-face results by luck. So you know our saying that we always do, if the p is low, the HO must go away. But in our case, the p is, in mine anyway, not low, so the HO must not go away. Right? Everybody seeing that? I got a p-value that is greater. So that means it's not low. So if the p is low, the null must go away. But if the p is not low, the null must not go away, which means what? We're going to keep the null. We're going to keep the null. It's not going to go away. It's not. Another way we say that is we say fail to reject the null. We're keeping it. We're not. It's not going away. We're failing to reject it. We're going to keep it. So right here, the p-value is greater. I assume those are the options they give there. Maybe let me get that up on my screen so I can make sure I'm showing you clearly what is being done there. I'm not familiar with exactly what options they put there. Let me see. The options they put are p-value is less than or greater than, right? It's greater than. So our p-value, so yeah, greater than the alpha. And then based on this, we're either going to go with reject or fail to reject. So we are going to go with fail to reject. We don't, it did give the option there to accept, but we don't really accept. We don't really accept. Why not? Isn't that the same thing? Not quite. It's kind of like the court of law, right? If I think I told you this last time, I was in a court of law a long time ago, a rape trial, sadly, and we let the guy go in the end. Not because I was sure he was innocent. If somebody said, "Oh, so you accept he's innocent?" I would have said, "No, I'm not sure he's innocent." But the evidence was just too fuzzy. All of us on the jury felt the evidence. Everybody was basically drunk, and everything was unclear. And so we didn't want to put the guy away for years and years. I mean, we sort of did, but we didn't want to make a mistake. And evidence was just not that clear. There was too much a chance. Like that's what's happening here, right? We don't accept the HO. Remember, the HO was assumed to be true. Like in a court of law, you assume innocent unless proven guilty beyond a reasonable doubt. So you assume that, and that's weak evidence, right? If evidence is weak, then you go with HO. Whereas H1 is always, every hypothesis test we'll ever do, this is the last type we'll do, strong evidence, right? So what are we doing? We are failing to reject the null. So we are keeping the null and not going with H1. Why? Because evidence is not strong. Why is it not strong? There's too big a chance of luck. There's a 37% chance that we could have got this higher, right here, this average for the face-to-face higher than the other two by luck. It could have been a lucky 8 students. I mean, it's only 8 students. If we had like 100 students, or maybe just 50 students, or even 30 students, then there would be a much lower chance of luck. The calculator would tell us If we had 30 students with these averages, there would be a way lower chance of luck. You can't get 30 lucky students like that, but you could get 8. There's a chance of that. There's a 37% chance that we just happen to get a lucky 8 students. Now, probably we didn't, but we're not sure beyond a reasonable doubt, right? We wanted the chance of luck to be less than 10%. That's what the significance level, that's how significant they want the results. Like a court of law says beyond a reasonable doubt. We wanted less than a 10% chance of luck. We didn't get it. We had a greater than 10% chance. Our P is not low. The HO must not go away. We're keeping the null, but that doesn't mean we accept it. We just can't reject it. So we say fail to reject. As such, the final conclusion is, what does that mean? Well, right up here, we're keeping the null, right? We couldn't reject it. We don't strongly believe the null. We never strongly believe the null. It's what we assumed in the beginning, like assumed innocent when somebody's accused. What do we believe? We believe all 3 averages are really equal. Now, we don't believe it strongly. We just couldn't reject it because evidence was weak. So we're going to say, no, there's not strong enough evidence to reject that. There's not strong enough. So we're going to keep thinking, as we did assume in the beginning, that all 3 methods, face-to-face, hybrid, and online, are all equal averages, right? That means those mu1, mu2, mu3, those are the averages. It's a Greek M, stands for mean. Mean 1, mean 2, mean 3. The 3 averages are all equal. So we are going with insufficient evidence, right? There was not enough evidence, weak evidence. There was too weak of evidence to support the claim that the course is a factor, that the delivery type is a factor. There's not enough evidence to support that claim. We're going with insufficient evidence. There we go.